Welcome back to Tech Garage. Now Brian has us all hooked up. Let's take a look. The intake manifold's on, done. We used our ARP bolts. He's got them torqued to specification. Remember, he worked from the middle all the way out. He actually put the thermostat housing on and has that all bolted up. But you know, we didn't put the thermostat in for a reason. Later we want to show you with this high flow pump here that Proform sent us, we want to show you the actual flow of the coolant, so we left it out. You don't want to do that. You want to make sure you put your thermostat in. Now it's time to turn our attention to that distributor. We got the distributor dropped in. This is our Pro Billet Msd Distributor. We got it dropped in, but we also have it timed. Well, how do we do that? I told you earlier. We took the spark plug out of number 1. We puffed it on the compression stroke. When we felt that puff, we took our harmonic balancer and we made sure we were right at top dead center, 0. And then I'll show you, if you pull this off, we dropped it in so the rotor button's actually pointing right towards number 1. Not so much the cylinder as number 1 on the cap here for the wire. You can see the wire here, 1, then we followed our firing order, 1865, whatever it may be. Just look at your service manual. Every firing order is going to be different, but remember to start at 1 and work your way around. Then we took our wires, our MSD, 8.5 wires, 40 feet of conductance and 1 foot of wire as we go down wrap. Man, we're going to get the spark down there. Good insulation, low resistance. We put it in our Proform wire harness here, our loom, and put it into our spark plugs with our big boots. We're not going to have any issues there. Everything's wired up there. Then we turned our attention to our coil. Now, we put a blaster coil on here. This is all a self-contained unit. This is pretty cool because it's real simple. If you look over here, we got the distributor that comes down. We had 3 wires. Couldn't be any easier. Orange, red, and black coming out. And then the plug from the coil supplied had the orange, red, and the black. So it was plug to plug, including one other gray wire was as simple as a tack wire. And you can see it right here, our blaster coil. This is 70-to-1 turn ratio. This thing's capable of putting out 40,000 volts. Well, you might not need 40,000 volts. Engine like this, idling, may put about 12K down at the spark plugs, but think about this, high compression, under pressure, extinguishing that flame on that spark plug, we got 40,000 to keep the boost going. So I got my red wire right here. It's tied into the coil, and then my other red wire's coming over to actual power supply down from the battery, just like the schematic says. Here's my orange wire. My orange wire is on the other side. Well, what does that do? It pulses the primary side of the coil, creates that magnetic induction so we can get the spark, but our distributor here has a little pickup that allows it to pulse. I told you it was all a self-contained unit, and then I have the gray wire going up to the actual tack. Being a self-contained unit, I got a vacuum advance here so I can advance and retard with vacuum. This one's not going to talk to the computer. You may have a system that talks to the computer, which is no problem. Holley gives you the actual link. You can plug right into it and it'll talk to the computer. Now it's time to turn our attention to the whole project. Ta-da! And the grand finale. We're talking about the EFI Holley Terminator, and it's as simple as just setting it on and plugging it in, and we'll be ready to go. But I want to explain to you what's the difference between fuel injection and carburation. Well, carburation, you don't need that computer and a lot of inputs. Inputs, think about your eyes, your nose, your ears, senses, sensors. And then we have a couple of outputs, and I want to show them to you. Holley's got them all built in with one plug. Couldn't be easier. You look right here on the side. You have a map sensor. Now my map sensor plugs right in there, and what's that going to do? Well, it's going to sense manifold absolute pressure. These are all about fuel delivery. As we start to lose vacuum, I'm going to need more fuel. I'm getting on it. I'm getting more power in there. I need fuel. This is going to sense that. We also have a throttle position sensor right here. It's located on this side. Once again, total unit. Throttle position sensor, you sweep it up and down, it tells the computer where the throttle is from 0 to 5 volts. It'll know if it's at half throttle, wide open throttle, why? Once again, fuel delivery, got to get the fuel in there. And then what you have is you have an intake air temperature sensor and a couple external ones we'll look at. Those are all inputs, sensors. Now outputs on the other hand, we have a couple of outputs. Fuel injectors are an output. Once the computer decides what all these sensors are doing, he can open and close these for the fuel delivery. And we also have right here what's called an idle air control motor. The idle air control motor allows air to bypass the throttle plates. See, on this system, the throttle plates are actually closed. So if I bypass air, it's like a controlled vacuum leak. It's going to be able to raise and lower the idle, which is really neat. And the cool part is, these are all just regular sensors, OEM sensors. You can go down to advanced and pick these sensors up. Even with your EFI system, and use them. And guess what? Your car in the driveway works exactly the same way. There's no difference. This is all high performance, cool stuff, but your car works the same way. Now, if you look right here on the screen, I can switch it over and you can see Holley gives us phenomenal instructions here. It all starts right here at the battery. Now the battery has a red wire and a black wire, heavy ground wire, and a heavy power wire going down to the PCM. Brian's getting that wired up all right now for us. Then we come up and we needed a couple external plugs. We needed an oxygen sensor, a coolant temperature sensor. There's an optional fuel pressure sensor, which is nice. Then I come down here to the fuel pump. Well, we'll wire that up a little bit later because there's a lot involved in that when we start talking about a return system. I come down, we plug it in, we're good to go. Now you can see them right here on our engine. Actually, our oxygen sensor is located down on the actual header assembly. We had to weld a bong in there. You're gonna have to do that on your exhaust system, and then you need an oxygen sensor. You don't have that with a carburetor. This is the boss. This is the big player. This is the feedback. Command corrects condition. This is the condition. So what's going on in that exhaust? Whether it's rich, the computer's going to tell this EFI system, take away fuel. If it's lean, senses a lean condition down in the exhaust, computer's going to tell this EFI system, add fuel. So you can see, this guy's a boss. You have to have him if you have an EFI system. One more is a coolant temperature sensor. Now my coolant temperature sensor is located right here. My coolant temperature sensor is going to go into a coolant jacket. And this one here is a negative coefficient thermistor. I know those are big words, but listen, it just senses the coolant, and with resistance either going up or down, tells the computer, hey, add fuel or take away fuel. Well, if the engine's cold, more fuel. As it heats up, we start getting better control on that fuel. And the cool part about this Holley system is that computer self-learning. It's gonna learn all that as this thing runs, and all these parameters that are going on with all these sensors, it'll get better and better and better the more you drive it. Well, now you understand how it works. We'll be right back with more Tech Garage presented by Advance Auto Parts.